Welcome to Task 4.5, Rewriting Rational Expressions. This is going to build on what we did in Module 3 with box division. So let's start off by talking about fractions in general. Now remember, rational functions are just a form of fractions that involve variables or polynomials. So let's take it back to fractions. What makes a fraction proper versus improper? So again, a proper fraction versus an improper fraction. Well, if you remember, proper fractions are fractions that are usually less than 1. So 1/3, proper fraction. 5/6, proper fraction. We could even have negatives. -2/5, proper fraction. 4/7, proper fraction. In all of these, the numerator is less than the denominator, or the numerator is smaller than the denominator, leaving us with a fraction, even the absolute value, less than 1. We don't have anything equal to 1. So what about improper? Improper, one definition you may find of improper is that we can rewrite it as an improper number, or as I like to say, a whole number plus a fraction. So let's make some examples here. 7/2. That is improper because 7 is greater than 2. 11/8. Again, improper because 11 is greater than 8. 5/3. Improper because 5 is greater than 3. And in each one of these cases, we can rewrite it as a mixed number or a whole number plus its fraction. So for example, 7/2 can be written as, well, how many times does 2 go into 7? 3 with 1/2 left over. 11/8 can be written as, well, how many times does 8 go into 11? 1 with 3/8 left over. And 5/3 can also be written as this whole number plus an extra fraction. How many times does 3 go into 5? It goes in once with 2/3 left over. So if we're just talking about fractions, something is proper when the numerator is less than the denominator, and something is improper when the numerator is greater. And the nice thing about improper is that we can rewrite them as mixed numbers or whole numbers plus a fraction. Well, let's translate this to proper and improper rational functions. So instead of looking at the number itself, we're going to be looking at the degree. A proper rational function means the degree of the numerator is less than the degree of the denominator. So just like the number itself, we're looking for the numerator to be less than the denominator. But instead of just the number, we're looking at the degree. So let's do some examples. So if I had x plus 1, I could put that over x squared plus 2x plus 3. All that really matters is that that degree of the numerator is less than the degree of the denominator. Another example could be x to the 4th plus x cubed minus 2x over x to the 5th plus 1. That right there would be considered, proper because that x to the 4th, the highest degree in the numerator, is still less than x to the 5th, the highest degree in the denominator. Go ahead and write yourself a few examples of proper rational functions to go along with mine. So let's talk improper. If improper as a number meant that the numerator was greater than the denominator, that's going to be the same thing for our improper rational functions, but in this case, it's going to be the degree. So the degree of the numerator is greater than the degree of the denominator. But if one of our classifications is that we can write this as a whole number or write this as a mixed number, what happens when the degree of the numerator is the same as the degree of the denominator? So let's say we have 4 divided by 4. We can rewrite that as 1. Let's say we have 11 divided by 11. We can rewrite that also as 1. So technically, these are also improper. The fact that we can write them as a whole number means they're also improper. So not only are we looking for degrees greater in the numerator, but we're also looking for equal. So a better way to think of this is degree of the numerator is both greater than or equal to the degree of the denominator. So let's write some examples. If my numerator is x plus 1, my denominator could also be a first degree x plus 5. That would be improper. If my numerator is x cubed plus 2x squared minus 5, my denominator just has to be either equal to or less than x cubed. So let's say it's just an x minus 1. One more example for us. Let's say the numerator is x squared plus 3x. Well, our denominator has to be at least x squared or less. So let's go ahead and say that denominator is just x plus 7. Each of these is considered improper because in every case, the numerator is a greater degree or an equal degree to the denominator. So I want you to label each one of those examples as proper or improper, and we'll go over those in class. But our big idea here is that if it is improper, we can rewrite it. We can rewrite it as a mixed number, as a whole number plus some fraction. So that's what we're going to do for our improper rational functions also. We're going to rewrite these as a whole number plus a fraction, or in this case, a whole polynomial. That's what this is showing you right here, a whole polynomial plus a fraction polynomial. So we're only going to do that when it's improper. So let's go ahead and let's scan through these first and determine which ones are proper and which ones are improper. I'm just going to be looking at half of them. I'm not going to do all 6 of them. I'm going to give you the solutions to half. So take a moment, scan through, determine which ones are proper, which ones are improper. So let's look at number 1. Number 1, we see that it's x squared over x to the first. Because the numerator's degree is larger, this one is proper. So let's rewrite this as a mixed number. And that's going to require some division. So we are going to set up our box division just like we did in Module 3. I'm dividing by x plus 2, so that goes on the side of the box. And I'm dividing into this numerator, so that's going to fill in the box. X squared, well, x times x has to give me x squared. Multiply that down, I get 2x, but I need a total of 5x, so I'm going to add on 3x. And put a 3 at the top because 3 times x gives me that 3x. 6, well, 6 matches up. We have no remainder. So we could rewrite this function as just x plus 3. Let's check out number 2. The numerator is x to the first. The denominator is x to the third. This one is proper. So we're not going to divide. Let's look at number 3. The numerator is x cubed. The denominator is x to the first. This one's improper. So that means we are going to divide. We're going to set up our box. X cubed requires 3 columns. and we're dividing by x minus 1, so that's what goes on the side. And we're trying to match this right up here. So I'm going to start by putting 2x cubed in the top corner so it matches. And let's start our division. 2x squared times x gives us the 2x cubed. So let's multiply straight down. Negative 2x squared. But I need negative 7x squared. So I'm going to subtract 5x squared. Well, negative 5x times x gives us that negative 5x squared. Multiply that down, I have a positive 5x, but I have no 5x's here. No 5x's, so I need to cancel out all 5x's. I need to do 5x minus 5x. No x terms, to be left with no x terms. So that means I have a negative 5 right here, because negative 5 times x gives me negative 5x, and a 5 in the corner. But I need to match 6, so I do have a remainder. Plus 1 is our remainder to get us back to that 6. So here's our solution. Here is the whole number, or the whole polynomial. 2x squared minus 5x minus 5. And here is the fraction, or the remainder. We have this only 1 left over, still being divided by x minus 1. Let's try one more. Let's try one more. And if you caught my error above, I accidentally said proper here. This one is, in fact, improper. So let's try number 4. And I'll let you guys try 5 and 6 on your own. But I'm looking at 4. I see that I have a degree of 1 in the numerator, a degree of 1 in the denominator. So this one is also improper. That means we are going to divide. We're going to write this as a mixed number, as some whole polynomial plus a fraction polynomial. So x to the first means we just need one column. Yes, this box looks super weird, but we're still doing the same process. We're dividing by x plus 2, so that goes along the side. And now I'm going to start filling in what we have in the numerator. 4x goes in that top box. And I need to multiply by 4, so 4 times x gives me 4x. Multiply down, 4 times 2 is 8, and I need to match that negative 1. So I need to subtract 9, and that is my remainder. That is my remainder. So our mixed number is that whole number, or that whole polynomial, minus our remainder that could not be divided. That 9 is still divided by the x plus 2. Okay, so there are some examples just to get you guys started. Remember, we only divide when it's improper, because just like improper numbers, they can be written as mixed numbers. So our improper rational functions can also be written as mixed rational functions.